equations. We know a lot about equations already. Remember Popeye and Bluto playing ping pong? Equations are just us trying to solve for an unknown variable, and we want to make sure that we can move terms from one side to the other. And we remember our rule that if we move a term from one side to the other side of the equation, all that happens is that the term changes signs. Well, in this lesson, we're going to make sure that we understand what an equation with one solution actually looks like, what an equation with no solution looks like, or what an equation that has an infinite amount of solutions, meaning any number would work for the equation, and what that looks like. So here's our first one. 2x minus 3 is equal to x plus 1. The very first thing that we always do is circle our terms. I'm going to put some faces with it as well. I've got a positive 2x. I've got a negative 3. There's only one single x here, so I know it's just 1x, and there's no sign, so I know that it's also going to be a positive. Now you can put a 1 in front of it if you want to or not. And then I have a positive 1. Okay, so the second thing that we want to make sure that we look at after we circle terms is which side of the equal sign, the left or the right, has the largest amount of variables. Well, on the left side, you see we have 2x. On the right side, I only have 1x. Looks like the left side wins. So we're going to keep that 2x where it is. And I'm going to ping pong or move my positive x over to the opposite side. What happens to this x when it moves to the opposite side? Well, that's right. We've got to make sure that it becomes negative. Okay, so if I combine these two terms together, I have more positive x's than negative x's. I have one more positive x, and so I could write it as x or just 1x. Either way, doesn't matter. I'm going to leave it as x, because x by itself is just one single x. Now, that takes care of the x's, but I still have this negative 3 here, and I got to move that out of here because I want to just get x by itself. It's called isolating the variable. So I'm going to go ahead and move negative 3 and ping pong it from one side of our equation to the opposite. When we ping pong it over to the other side, what happens to negative 3? Well, that's right, it becomes positive. It switches the sign. And so now we can combine our numbers together because these don't have any variables. So positive and negative numbers, they can go together. When we combine these terms, 1 plus 3 is going to give us 4. And so what we see here, we have an answer x is equal to 4. We know that this is one solution. And the reason is because we've solved for the variable. What you're going to notice coming up is that the variables will cancel each other out if there's no solution or infinitely many solutions. But since we've solved for a variable, and it's very clear to see that x is equal to 4, this is one solution. X can only, in this equation, be the number 4. All right, so we've seen what one solution looks like. Let's take a look at another one. What you're going to notice when you find an equation that has no solution or infinitely many solutions is that the variables will be the same on both sides. If you circle your terms here, you're going to notice the 2x is positive, the 6 is negative, the 5 is positive, and the 2x is also positive. And if you look carefully, we've got 2x on both sides. Well, when we ask ourselves the question, which side of the equation has the bigger variable? Well, there's no answer to that. Both sides have the same variable and the same amount of that variable. So it doesn't matter which one we take and ping pong over from one side to the other. So I'm just going to take the one here on the right. Again, it doesn't matter. Ping pong it over. And what you're going to notice is that it becomes negative. What happens when we go to combine our variables together, combine these terms? Well, these are what we call additive inverses. Additive inverses always combine to make 0. So negative 2x and positive 2x, yep, those cancel each other out and form nothing. They form 0. So take a look at what's still left in our equation. On the left side, we have a negative 6. On the right side, we have a positive 5. And our question that we have to ask ourselves is, are these two numbers equal to each other? Which means, are they the same thing? And the answer to that is no, negative 6 is not positive 5. So the answer to this type of equation is that this has no solution at all. These two numbers are not the same, and we didn't solve for x because x canceled itself out. So there is no solution. Whenever you have two different numbers that are trying to say that they're equal to each other, nope, it's not going to happen. It's no solution. All right, last one. Let's use our rules and what we know about equations and what we've learned in the previous two examples to see if we can figure out this last example. Negative 8 plus 3 is equal to 3x minus 8. And I think this is going to be pretty obvious once we start circling terms. I've got a negative 8. I've got a positive 3x. On the other side of the equation, I have a positive 3x, and I have a negative 8. Okay, so what we are going to look to do first is the variables. We always want to take care of variables first. And we look at both sides, and wait a minute, once again, there isn't a clear winner as to who has more variables, the left side of the equation or the right side. It's the same. Both sides have 3x. So again, it doesn't matter which one we move from one side of the equation to the other. We're going to form those additive inverses again. All right, so I'm going to grab this one. Again, it doesn't matter. If I ping pong it from one side of the equation to the other, it's now going to become negative. And what we notice when we try to combine our variables is that, again, we have additive inverses. Remember, additive inverses always form 0. So negative 3x and positive 3x, they'll cancel each other out. Well, what are we left with? Well, on the left side, we're left with negative 8. And on the right side of the equation, we're also left with negative 8. Are those two numbers the same? Well, looks to me like they are. Negative 8 is the same as negative 8, which means we are going to have an infinite amount of solutions. When we have two numbers that are the same, and they're saying, hey, this number is equal to that number, and they're identical, that's an infinite amount of solutions. Let me show you how it works out to be an infinite amount of solutions. What an infinite amount of solutions means is that we can plug any number in for x. Let's take a look at our original equation, and I'll show you how this works out to be an infinite amount of solutions. What this means is we can put any number we want in for our variable, and it will always come out to be equal on both sides. So let's try the number 1. If I'm going to substitute the number 1 in for x, that means I'm going to put number 1 here and here. So that means we're going to have negative 8 plus 3 times 1. And we're going to say that's the same thing as 3 times 1 minus 8. Let's find out if it's the same. 3 times 1 is 3 on both sides. And we also have negative 8 still. Okay, I have 8 negatives and 3 positives. I definitely have more negatives than positives. That gives me a total of negative 5. On the other side, I have 3 positives and 8 negatives. I definitely have more negatives than positives. That also gives me the answer of negative 5. Let's try another one just to be sure. This time, I'm going to try a negative number. I'm going to put negative 2 in for our variable of x and see if this will work out on both sides. So I have negative 8 plus 3 times negative 2 on the left side, and I have 3 times negative 2 minus 8 on the right side. Well, when I multiply a positive times a negative, remember Mickey Mouse, my positive is 3, my negative is 2, so my answer has to be negative, and 3 times 2 is 6. So I end up with negative 6 and negative 8 as my two numbers on the left side. Same thing on the right side. 3 times negative 2 is going to give me negative 6, and I still have this negative 8 here. Well, it's pretty obvious that the two numbers on the left side are the same as the two numbers on the right side, and when we put them together, they're all negatives, so we're going to get a total of 14 negatives on the left and 14 negatives on the right. So you can see it's going to come out to be the same number no matter what we substitute in for x. And when it comes out to be the same number every single time, we say that it's infinitely many solutions.